Hey everyone, how are we doing? The lighting's actually good today. Is anyone here who's all in the chat? Got the black t-shirt. I feel like need a haircut, and then I'm like, oh, is my hair? They're all like, Noel, Braden, good to see you there. I had some interview stuff, not for me. I was helping interview people. Don't worry, I'm not leaving. Mubot is still down. I found some stuff about it that other people are reporting that Streamlabs plugin is being detected as a virus, so I'm not the only one. Might do a special intro today with Mubot and need to film it between classes, but yeah. Mubot quit. Check it out right here. This is the issue we're running into. I'll show you on the main screen. Streamlabs plugin for OBS detected as a virus. So multiple people are having this issue right here. Just started for me. This is 4 days ago, so it happened to people over the weekend. So I try to run, might even show it here, I think on the downloads. Streamlabs virus detected. I re-downloaded it and it's saying it's a virus. I need to go in and like make some changes, but Mubot is currently on leave. He has quit for the moment, but that is Streamlabs apparently a virus. So hopefully we don't lose Mubot. Like hoping his memory doesn't get erased. He doesn't get neuralized. I saw on Canvas a warning about scams too. What was the warning on Canvas? Uh-oh. Let me see this. I didn't post anything. What's the warning on Canvas about? Is it just a general? Yeah, there's always scams. Is something coming through Canvas or something? What's this all about? Let's put on a little chill music, then we'll get serious here, get started. What's this? Is it just Canvas saying like paid vacation? Is that what the scam? Yeah, I don't trust anything about that. What is this? What is this? Paid? Oh, Mubot's on paid vacation. I thought it was like a UT. A general announcement? Yeah, they do that. They're like, I'm gonna make an announcement to you on Canvas. I thought my door opened. I was like, what's going on? Here it is. Beware of new IT scam targeting students. There's a new scam targeting students. Campus scammers are sending emails pretending to be from OIT and telling students their accounts will be terminated unless they provide their personal information to verify their accounts. Yeah, basically, if you ever get an email or call or anything, I never go through links. Gosh, I hope I haven't scared me if they're pretending. Well, usually you can tell it's not them because you can look at it, but it's better to go like Google things, like Google OIT if you have to change things. Yeah. Want to score a point against Florida? Learn how to vote. Wait, what? Want to score a point against Florida while learning how to vote in the upcoming election? I thought it was like, I'm just utterly confused. I'm utterly confused. Do not create a guest account. Enroll in this free program. Okay, cool. Should we do some Chapter 8 regression? Who wants to do Chapter 8 homework and get that out of the way? You know, I don't know what it is either. Want to score a point against Florida? I thought it was like, what's going on? I'm gonna go tell Florida about that. Go tell Florida. It was yesterday. I got a call about my loan. Mubot broke. Everything was just on fire yesterday. Chapter 7 quiz? Yeah, when you want to do on Chapter 7 quiz? What should we do on Chapter 7 quiz? Which questions are you working on? We could do Chapter 7 quiz today. Which Chapter 7 quiz questions? Chapter 7 quiz. Tell me the question. We'll do the question. Just give me the first part of the question. There's a lot of Chapter 7 quiz. Got it over here on the main screen. Pull up a Word document. Name the question Chapter 7 quiz. We'll start working on it. Chapter 7 quiz is one of those ones that people say, I have no idea how to do this. But it's not too bad if you learn the steps. So we will try to learn the steps here and do Chapter 7 quiz. Which one should we do? Here's the main screen. Let's check it out. Okay, Chapter 7 quiz. The manager of a bookstore. Manager of a bookstore is interested in the amount of sales they're doing. Here's this one right here, manager of a bookstore. Let's mark it in here. They're interested in their sales and salespeople working. So the thing with these questions is you want to figure out what you need to know. So the manager of a bookstore. So it's not about solving this question. It's about knowing how to solve every single question we get that looks like this. What are they asking for right here? What are they asking for right here? Let's just review what this question is asking for. This is asking for the what? B1, you should know what that is the what? What is B1? We're just figuring out how to solve this right now. What is B1? Just what is B1? So if we go back, we might still have notes open from yesterday. We do have some notes open. What is B1? That's R squared. We don't need R squared. What is B1? It's the slope. Guys, guess thank you, Christopher, right there. They got it. Noel got it. Also, Braden got it. We have y hat equals b0 plus b1x. Mubot is here in spirit. He'll give us points later. Y hat equals b0 plus b1x, where this is the predicted y is equal to the intercept estimate plus the slope estimate plus the name of the x variable, whatever the name of the x variable is. So we need to know this equation. We need to know how to write out. The other big equation for this chapter is a residual, which is E, is equal to the actual minus the predicted, which residual equals actual minus predicted. And we need to know visually what these look like, which we covered a lot yesterday. But if we look right here, first thing is find the slope. Yes, we'll be doing that here next. You got it, Noel. The next thing is, after you find the slope, what the slope? So you need to be able to know what the slope is. Then you need to think of an I word, what the slope. After you find the slope, think of an I word. You need, if Mubot was here, we could write slope and he'd give us the what of a slope, which you have to do on the test. Not the intercept. Interpretation. For each 1 unit increase in X, we expect Y to increase by B1 units. Now, they might not do exactly that, but I always write it out that way. For each 1 unit increase in X, we expect Y to increase by B1 units. Try writing that out, try practicing it. After we do the slope, we are then finding the what right here for this problem. So don't worry, we're just walking through and seeing what we need to be able to do as tasks. So be able to find the slope, be able to interpret the slope, be able to find the what, which basically tells you what B0 is right there, which you've already said the next one. Be able to find the what. What do we find next? We already found slope. We interpreted slope. Now we find what, and then which is called B0. B0 is called what? This is just review right here, helping us make sure we know what B0 is. B0 is the quantity of the what? The intercept. And then we interpret the intercept. So there's find the intercept, interpret the intercept. When X is equal to 0, we expect Y to equal B0 on average. And then we ask, is that logical? And then next we write the regression equation right here, which is y hat equals B0, whatever we get for B0, plus B1x. Next, it says if 15 people are working, which is a value of X, what is the predicted sales? So it's basically solve for y hat right here. So that's a solve for y hat. And then if sales are actually this, what is the residual? That is find E. And then was it under or overestimated? So if you notice right here, I've got some notes on what I need to be doing. Let's go ahead and solve it with jump. So here's how to solve the problem. Go ahead and click your data and go right here and click the copy to clipboard. I'll do it slowly. Please slow me down if you have questions or if you get stuck. Copy to clipboard. Now hit Control-C or Command-C. Notice that you see up here column headers. We're going to go into jump and paste with column heads or paste with column names. Column names, that's what it's called. File, new data table. File, new data table. And then edit, paste with column names because there's column names. So you paste with them. Once again, I want to repeat, if you don't paste with column names, you'll see red right here. If you see red, that's bad because this is categorical because it put the column names in the first row. You don't want to see that. You want to see over here where it's blue, meaning quantitative, because these are quantitative, like how many people were working and how much sales were in thousands of dollars. So we now have the data inside of jump right here. And let's go here to Analyze, Fit Y by X. Analyze, Fit Y by X. Under Analyze, Fit Y by X, you have to figure out the X and the Y. So what is the Y? People working or sales? Sales or workers? What is the Y? Think about for a business, they'd be asking, why do we have this? Y is the thing we want to understand called the variable of interest. X are the explanatory variables. So when you think of X, they're the explanatory variables. They explain why something happens. Sales is the why. Why do we have so much sales? Maybe workers explains it. Great job, Noel, right there. I can't give out points. But maybe number of workers explains why there's so many sales. Look how I do a circle when I explain this. Does number of workers explain why we have so many sales? Why is the question? Why do we have sales? Maybe workers explains it. Now we're going to go here and look at the model. Now, the first thing I'll ask you is QQ straight enough, no outliers, plot doesn't thicken. Those are the four. Think of a C word to check regression. I said QQ straight enough, no outliers, plot doesn't thicken. Those are the four whats, and you should write them down and memorize them. Those are the four what. Think of C word to check a regression to make sure you're doing it properly. You can call X the independent. I don't love calling it that. It's just another terminology, more mathematical. It is the independent. I like to call it the explanatory or the predictors. But I prefer to say X are the explanatories and Y's are the responses, because we talk about Y's, we respond to them and we talk about them. So what are they're the four somethings. Q, Q, straight enough, no outliers, plot doesn't thicken. I'm going to check them here. Those are the four. Think of a C word. Great answers, Noel. QQ, straight enough, no outliers, plot doesn't thicken are the four whats when doing regression. Lots of review today. QQ, straight, kind of context, kind of conditions. Conditions are the things we have to check or make sure are met to be doing regression properly. If you don't have two quantitative variables, you won't get a scatter plot. Scatter plots are required for regression. The relationship needs to be straight enough, as in a straight line well approximates the relationship. There should be no extreme outliers, like a dot way up here would be an outlier, so we're good on the no outliers. And last but not least, when we say plot doesn't thicken, and just so you saw, I clicked up here to the fit line. If I did that a little too quickly, that fits the line to the regression, to the scatter plot. And when I say plot doesn't thicken, you have to go down here to the linear model and add a residual plot to it by going to plot residuals. And when we say plot doesn't thicken, we don't want to see any thickening on the residual plot. That's the plot we're checking to see if it thickens. And thickening, although you might say, is that thickening in this area, like it's thicker here than it is here, it's probably due to a lack of data. There's really not a lot of data down here over here. I don't think there's really thickening with this model. And also it looks straight enough, like the line looks to go through the center of the data. Straight enough would have problems if your data looked like, I'll show you really quickly. Straight enough is going to have problems if your data looks like this, because then when you fit a line, the line's not straight enough. Plot thickening is going to have a problem if it looks something like this right here. Is this model getting weaker or stronger as you go higher in the X's? As you go higher in the X's, is this model getting weaker or stronger? As you go higher in the X's, is that model getting weaker or stronger? It's getting stronger. Great job, Noel, because it's tighter. Notice how the plot is thicker in some areas, so we want to see the same strength throughout. So that would be a violation of plot doesn't thicken. You'll also see it in the residual plot. We talked about residual plots in our class, where all you have to do to make a residual plot is make the line flat, or I'll take away that arrow at the bottom. But a residual plot is literally taking the same plot you have. Check out lecture where we go over this. And to make a residual plot, you literally take this model and you make it flat. And then you can see the residual plot by looking at this right here. So the residual plot is the line flat. I erased points there. We don't want to do that. But now you can see how far the points are away with a residual plot. Once again, you can see it over here inside of jump that we have the residual plot right here. Notice how this point is way above this blue line right here. It's that same point right there. Literally, it's just above the line. So that has a positive residual. This one has a tiny negative residual, and you can see it right there on the residual plot because it's slightly negative. So what is the value of the slope? What is the value of the slope? Can anyone tell me what the value of the slope is? Making this just prettier. What is the value of the slope? Sure. What is the value of the slope? So you should be able to read a regression equation and find the value of the slope. What is the value of the slope? It is 0.892. Great job. I also want to point out that the value of the slope can be found under the estimate of the slope. So when you're looking at regression output right here, you should know this. A lot of people say, do I use jump on the test? And I say no, but you do have to know how to look at jump output. So when you're looking at this value right here for the slope, there's the slope, and there's the estimate of the slope right there. Intercept, estimate of intercept, name of x variable, long. I made it shorter. So that's the information right there where we have predicted y hat equals b0 plus b1x. And that's a lot of the information we need to solve this problem and other problems that have you use jump when doing regression. So we're going to take this information. I'm going to put it over here. Let's do a tool screen. Where's our tool screen? Where's our other thing? There it is. Okay, here you go. So I'm going to disappear real briefly. I'm addicted to Monster Energy drinks. It's bad. Round to 3 decimals, 0.892. And this means for each additional worker, for each additional, on the next exam would be shown jump images. Just, you could be given just like this, and then you would need to route your answer. For each additional X, we expect Y to increase by B1 on average. So use your interpretation skills and interpret the slope for me here real quick. Who can interpret the slope? Interpret the slope. Don't look at theirs. Go ahead and interpret the slope. For each initial increase in worker, we expect sales to increase by, yep, and that's in thousands of dollars. That is correct. Great job, Brain, right there. And because it's sales in thousands, and I've erased that. It means that on average, an increase of, no. It means that on average, the total sales will equal, no. It means on average, an increase of B1 salespeople working is associated with each, no. It means on average, the number of salespeople working is approximately, no. It means on average, an additional increase in this much in sales is associated with each additional worker. I really don't like the way they did this. I would prefer to say for each additional worker, we would expect an increase of $892 because you're timing it by this. Does that make sense, Braden, right there, why it's D? For each additional worker, we expect on average sales to increase by this amount. They're just kind of rewording this right here because this is for each additional salesperson. It's at the end of this. For each additional salesperson, we would expect for sales to increase by this amount right there. So just the rewording can get you sometimes, but you have to look right here for each, with each additional worker is the start of what I wrote. For each additional X, and X is worker. Yep, that's just tricky. They really like to be tricky with that. The intercept, go ahead and write the intercept while I put in the value of the intercept. It wants it to 3 decimals, so we got to do one more decimal. What is the value of the intercept right there? Or how do you interpret it? What is the value of the intercept? Which isn't really logical, which I don't know if they say, because it's when X is equal to 0. So go ahead and try to interpret the intercept. You will do this on the test. So when X is equal to 0, we expect Y to equal B0. So what would be the intercept? This is on the test. So if you're doing this now, you're getting great practice, and then we can figure out which answer looks most like it. So when X is equal to 0, we expect Y, and I've got everything color-coded highlighted, to equal B0 on average. So what would that be? Don't worry about their answers, because on the test, you will not probably be clicking. You don't click a lot of answers. You have 12 points of interpretation. So if you know how to write it out, you better. With number of workers equal to 0, we expect sales to equal 860. Yep, but this is not logical because if no one is working, you can't sell anything. Boom, Brayton, I was going to hit the points button. You're exactly right. And exactly, there was no, great job, Noel, too. And so this means on average, the total sales will equal this. Nope. This means on average, the expected sales of this with 0 salespeople working. It does not make sense because it's unlikely that there'd be any sales if people are working. Exactly. And so it's this one right here because the expected sales with 0 people working is what the intercept is. Now we're just going to go in and plug into 3 decimals the numbers, 8.652, and B1 right here is 0.892. And now it says predict for 15 people working. So I'd go back over here, and what do I do with my equation to predict if there's 15 workers? Very important, a lot of this on the test. What do I do with 15 people working? What do? I simply what? To make a prediction with the model, just plug 15 in. There you go. Now the model's going to make a prediction right here. And we just go over here to the calculator. And this will be the predicted sales, not the actual sales. This is a Y hat. Make sure to write down in notation, this is Y hat, meaning predicted. As long as you do your math right, I think there's a 2 after this. Sure, I think we're good. Hopefully I didn't round any decimals improperly. This is the predicted sales in dollars, but it actually wants it in thousands of dollars. So you need to multiply this by 1,000. Hopefully I haven't done a rounding issue. We'll find out. Round to the nearest $10. There you go right there. Now, this is the predicted, this is the actual. Here's what I want you to do. Is the actual above or below the predicted? So here's the actual. Is the actual above or below the predicted? So is the actual above or below the predicted? It's above. The actual's above. And what you want to do, and good answers, Noel, right there. You want to say y equals, because y is the actual. They actually made this amount. They were predicted to make. So you just have to what these two numbers. You just have to what these two numbers. Minus them, exactly. And because the actual's higher, you get a what residual? Because the 23,000 is higher than 22,000, you basically get 1,000, and the residual should be what? Because the actual, which is the dot, is higher than the line prediction. So these would be the predicted sales right here. That's predicted sales right there. And so that's the prediction from the model. And then the actual we'll do in a UT orange. So the actual is that. That's not the residual. It's the actual. So there's the actual. There's the predicted. And positive residual, exactly positive. And then the residual is this right here. And that's the distance between the two. So it should be 970. And you just subtract the actual minus predicted to get the residual. And we do our little drawing. And has the model under or overestimated it? Has the original estimate for part F an under or overestimate? So here's our estimate. Is that an under or overestimate? Hopefully I got everything right. Long question. Is that an under or overestimate? It's an underestimate. We underestimated it because the model is the estimate. Check answers. We got 100. That is a tough, long question right there. That's a tough one. That is a tough one. And you have to be very careful along all the steps with each part of this. So that is a really amazing question right there. It took us about 18 minutes to do. But if you notice, we reviewed, we basically did almost the whole chapter. If you looked, we did interpretation of slope, intercept. What is the only quantity we didn't interpret? What is the only quantity we didn't interpret that you will interpret on your test? And I'll do it for you, since you've done so good. If you just tell me the quantity that you did not interpret in that, I'll go ahead and interpret it. What quantity did we not interpret? What quantity was not interpreted that will be on the test? As write the interpretation of it. What quantity was not interpreted? So we have slope, intercept, and there's one more thing to interpret. The last thing you'll have to interpret is what? Yeah, like R squared. 91.86% of the variation in sales is explained by number of workers. 91.86% of the variation in sales is explained by the number of workers. Blank or times 100%, R squared times 100% of the variation in Y is explained by the variation in X. So 91.86% of the variation in sales is explained by the variation in workers. There we go, and that's how we interpret it. Let's do another one. What question do we have next right here? What should we do next? That was a good long, here's an R squared one. So we could do you have any tips remembering what values go? I'll write them down and you'll say them twice. So when you do the intercept, you say when X is equal to 0, we expect Y to equal B0. And then when you do slope, you say for each 1 unit increase in X, we expect Y to increase by B1 on average. So if you look at the pattern, it always goes 0x, y, 0, 1x, y, 1. Does that make sense? So the pattern of it is 0x, y, 0, 1x, y, 1. So we say for each 1 unit increase in X, we expect Y to increase by B1. When X is equal to 0, no, that one's X0, Y1, X0, Y0. Sorry, I thought it was. When we're at 0 for X, you can say that. When we're at 0 for X, we expect Y to equal B0. So you could say, when we're at 0 for X, we expect Y to equal B0. When we're at 0 for X. So I'm putting the 0 first now. But you'll do like, does that make sense, Noel? You say 0 twice with the intercept, and then with the slope, you say 1 twice. For each one, it's practicing it. It's writing it down. Write it down by hand. Try doing an interpretation. We'll do a lot in class. And just the more you do, the better you get at it. So like this one right here, they're giving us, I'm going to mark this in the notes, they're giving us R right now. And I got this one wrong yesterday. What do we do with R to turn it into R squared? What did Brian forget to do yesterday with R to turn it into R squared? Which R squared is not R. I just thought they gave me R squared. So I didn't think R squared was R, or R was R squared. I didn't think that. I swear it was R. I was just like, oh, that's R squared. No, it's not R squared. That's R. Not square root it. So in good answers, that's R. So we square R to get R squared. If you have R squared, you square root and check the direction to get R. Does it like to retake? Yeah, it does. Great job, Christopher. You can retake these. The manager of a bookstore. R squared. R squared question. So we're going to take this R squared right here of 0.941, square it, and it's 88.55. Notice that I'm going to times by 100, round to 2 decimals for 88.55. Now we go in here, and we have to remember, we want to understand sales. So the variation in sales is what we're understanding. So that means we are trying to understand the variation in sales, which makes it A or D. I don't like the way they phrase the end of it. They say for a regression model with Y on X, so was it 88.5? It's 1 decimal, so that might round to 88.6. Let's double check. It is going to round down to 88.5, just the 1 decimal right there, 88.5. And that should be the right answer. Haha, that question can't stop me now. But this is blank. I preferably would say 88.5% of the variation in sales is explained by the variation in workers. Preferably, that's the way I would go with it. 88.5% of the variation in sales is explained by the variation in workers. They're saying accounted for, same wording, no difference. So, wow. Owen Wilson knows right there. Okay, another one. We did this one yesterday too. No, this is an R squared one. Let's do another R squared. What is the interpretation of R squared for this problem? Looks like we're going to have to find R squared. So let me put the notes in right here. And distros. Can I do the full? I don't have enough time to do them all. Get through a lot of them today. So we're going to copy this into jump right here. Copy to clipboard. Copy right here. New York City. Let's do it next. You got it, Noel. We're copying this with Control C or Command C. Go over to jump and go File, New. Sure. File, New, Data Table. File, New, Data Table. With File, New, Data Table, we're going to go to Edit, Paste with Column Names. Once we paste here with column names, we need to make the model by going to Analyze, Fit Y by X. Analyze, Fit Y by X. Now we want to figure out, what are we trying to predict? Well, price is what people are usually interested in when buying something, so that's the why. Why do things cost a certain price? Maybe the capacity of the hard drive explains why things cost a certain price. Capacity is the explanatory variable for why price costs so much. Here's the model, and it looks pretty darn good. We're going to go ahead to the red arrow and fit a line to it, which is the linear model. QQ, straight enough. No outliers, plot doesn't thicken. And we actually look pretty good. Nothing's too bad. A little waviness. We can look at the residual plot to see if anything weird is going on. Not too bad. A little, not too bad. So there we go. There's the model, and the R squared is ridiculous. 99.78% of the variation in price is explained by the variation in capacity. Know how, if you're watching me right now, I'm basically giving the answers because you should know how to look at an R squared here and go, blank percent of the variation in Y is explained by the variation in X. 99.78% of the variation in price is explained by the variation in capacity. 99.78. Let's go back and put in the answers and do another question. 2 decimal places, so we have it right here, 99.78% of the variation in price. It's asking the R squared twice. Sure. Indicates the variability in price of these disk drives that can be accounted for by the variation in capacity, and that is literally just an R squared explanation. The whole point of this question is, can you explain R squared? But you are writing this out on the test, so I can't state it enough that clicking these buttons is not enough. You have to know how to look at this value right here and be like, oh, the R squared is not R. That's a good thing to know. It's the percent of variation Y explained by the variation in X. So 99.78%, because the decimal is 0 through 1. It's going to be 99.78% of the variation in price. The Y variable is explained by the variation in capacity. And that's got it. Let's go find that New York initiative. New York initiative. Thank you, Noel and Braden and Christopher. If you have any questions, let me know. Those are little ones. A lot of those. Residual plots. New York Initiative. Okay. I bet we could do like 6 more questions. Burn through them. Stat to a 1, chop to 7 quills. The New York City Data Initiative. What are they doing with data? Okay, oof, this one gets me sometimes, so let's watch out. Here we go. So they've got year. Do you think they want to predict year or water consumption? Do you think they want to predict year or water consumption? What do you think is of interest to them? Year or water consumption? What do you think they want to predict? Year or water consumption? What do you think is of interest to them? Water consumption. So that would make water consumption the Y and year the X. So let's see how they explain this. Not one of my favorite questions. Oh, what's the correlation? Did they tell us it? It's negative. I'll tell you that much. Oh, there's the R squared. Oh, they are. Oh, that's so nice. So here we go. What are the variables and units in the regression? Water consumption in millions of gallons per person. Water consumption, millions of gallons per capita. That looks to be it. Water consumption is in millions of gallons per capita, because that's what it says right there. It's not the R squared. It's not the... That looks good. What are the units of the slope? Wait, what are the variables and units in the regression? Population, water. That looks right. What are the units of the slope? It's going to be per year. Millions of gallons per person per year. That sounds a little bit right. Years per millions of gallons per person. No. So it's the millions of gallons per person per year, I believe. Good to see you there, random person. We'll see if they get to stay. Millions of gallons per person per year. And now we get to what is the correlation. Now here's where we run into the problem and we hit a test question. I clearly saw that the correlation must be what? I clearly saw that the correlation must be what? Take a look at the screen right now. I clearly saw that the correlation must be what? Negative. I clearly saw that the correlation must be negative. And with the correlation being negative, we take R squared and we what it now? We take R squared, turn it back to a decimal for the moment, and we what R squared. So we take R squared and we what R squared. Oh, maybe I shouldn't have liked them. I think they said, how are you? I am good. Person who came to the channel. Thank you for asking that. I was trying to figure out what was said. Well, we're not going to square it. So this is already R squared. So think about this. If we have R squared, then what do we do to R squared to get correlation? Unsquared, right? So we have to square root it. So is that the answer? Is that the answer right there? So it was R squared, and we're going to square root it to get R. So is this the answer? No worries, no worries. R squared, square root it to get R. R, square it to get R squared. No worries, Noel. Good practice. Just remember, R is correlation. R squared is correlation squared. R squared can be turned into correlation by square rooting R squared. Why is it not the answer? I just square rooted it. Why is it not the answer? Because when you go from R squared to R, we square rooted R squared. Christopher, you're right. Great job, Christopher. You're right. Because remember, if this is negative and you square it, you will get R squared right there. And then when you square root it, you don't know whether what you squared to get it was negative or positive. So you have to go in here and make it negative. So there it is right there. It has to be negative version of that. Millions of gallons per person per year. I actually misclicked. I almost made a wrong answer. We should get everything right. Check answer. We got 100. Yeah, I know. No, it's super important. No, and Christopher, good answers right there. And I wish I could throw you some points. This is one people often miss and is on the test. Like when you're going from R squared to R, you have to square root it and check the direction. It's on the Canvas content. So don't forget checking the direction. A lot of people forget to do that. Very common mistake. When you go from R squared to R, check the direction. Let's see. There's a whole bunch in here. Any other ones? Let me know. These are not too long of questions right here. Start to 3, start to 1. Exactly. So if the graph was positive, we would not need to do the negative version. Only because it was a negative direction do we do the negative R. Good question. So they found an R squared. What is the correct interpretation of this number? Don't read their answers. They're trying to explain GPAs of students, student jobs. Sure, it's interesting. Oh, their GPA number of hours worked. So what do you think she wants to understand? Students' GPAs or number of hours worked? We're not giving a graph. We would just put in correct, but we don't do that on the test. Good answers, Braden. Yep. You would have to put in plus or minus. Like it could be one of the two. Like if you're just given R squared and you say, what is R? You could say it was either plus or minus this. Good answers, Braden. But we don't do that. We could. It's good. Like what are the values of possible values of R? You'd have to say it could have been plus or minus. That's a good question. So what is the Y variable of interest in GPA? And let's not do that. What is the Y variable of interest in GPA and number of hours worked? I'm going to double check right as I'm reading it. What is the Y variable of interest in GPA and number of hours worked? What do you think is the Y? For students, what do you think it would be? I don't love their answers. Probably GPA. Well, you see, this one makes the most sense. You might be right, Christopher. She might be wanting to understand how much students work. Does it say that up here? This one actually looks one of the best to me. But if she... I don't love any of these answers. 12.7% of changes in GPA can be accounted for by a linear model on work hours. That's probably the best. You can get mad at me? I'm just gonna not take through. Don't love their answers. Would it be the GPA affected by the person? I know we're cooked. No, it's. So I want you to know how I narrowed this down. You ready? First of all, no, good questions, Christopher. Christopher, you're cracking me up, man. I narrowed it down to these two by figuring out the what. I narrowed it down to these two by figuring out the what. I narrowed it down to these two by figuring out the what. You're cracking me up too. How did I narrow it down to those two? By figuring out the what. I wish the question made it a little more clear though. I narrowed the Y variable. Because blank percent of the variation in Y can be explained by the variation in X. And then I noticed that they're saying whether or not a student works, that's a categorical variable. So whether or not a student works is not what they measured. They're looking at the number of hours a student worked right here. So I would preferably say 12.7% of the variation in a student's GPA can be explained by the hours a student works. So what first I did to figure out this question was went right in here and said, what's the Y variable? Okay, that's the one we're trying to explain. And then I figured out what is the X variable. It's going to be number of hours a student worked. And I don't use the word accounted. That's why I prefer just write it out. 12.7% of the variation in GPA can be explained by the variation in hours worked. And then I have to figure out which one my Pearson's trying to push me towards. This question's got to go. But it's a multiple choice and the answer's on the screen. It's a freebie. With the video, if you get that one, you can just click to the video. Okay, so Christopher, we're gonna let you pick right here. Should we keep this question right here, question 1, or question 4 right here? Or question 5? Should we keep question 1 with multi-part, or question 4? With a multiple choice that doesn't change, that's the same answer every time, that's just interpret R squared, blank percent of the variation Y explained with the variation X? I would hope you'd say, let's keep question 4. That's an easy one. It doesn't change, even though my Pearson's, I guess 4, you got to get exactly. But the thing is the answer's in the video now. So if you check out this video, I could ruin our keep 1. Oh man. Okay. Here, we're gonna do this right here. Help me out here. What are we given for this model? It wants us to make a what using this? It wants us to make a what using our model. So help me out. It wants us to get the what value from the model. This question wants us to get the what value from the model. What value does it want us to get from the model? The what value from the model? The y hat, the estimated value. So this one's super duper easy. All you have to do is it says predicted potassium. Notice how we get the model right here. What do we do to solve this? It says predicted potassium is equal to 38 plus 28 times fiber. So what do we do? What do you do? Solve it. So how do you solve it? Because this is plug 10. And that's going to be 280. 280 plus 38 is equal to 318. And you're done. If the cereal actually has 320 grams of fiber, what is the residual? If it actually has 320, what is the residual? If it actually has 320, what is the residual? What is E if it actually has 320? If it actually has 320, what would be the residual? What would be the residual? What is the residual if it actually has 320? If it actually has 320, what is the residual? 2? Yes, Noel. Noel, I wish I could give you points.
Wow.
Owen Wilson, wow, right there. You're right. Because it's 2 higher than its prediction. Does that make sense what a residual is? It was predicted to be 318. That's where the line is at. It's actually at 320. And it's 2 higher. It's plus 2 higher. So the residual of 2, positive 2, means it's 2 higher. Great job. And then you did the residual formula of residual equals actual minus predicted. And you can say 2 is equal to 320 minus 318. And this is its actual value of y. The problem doesn't ask that. But these are the things we should be able to do. Be like, well, what if it actually has 320? Well, then the model was 2 lower, but it's 2 higher than the model. So it is a positive residual. Does that make sense, Noel? Just additional questions to practice. How many screenshots do you Word documents and screenshots a lot. Yeah, I screenshot everything. You're right, Braden. I screenshot a lot. Once again, another one right here. We can just burn through these. Let's try to do 3 more questions before class. So what do I do with this one here? Just tell me. It says, what does the model suggest the mileage would be? As I take the note right here, just tell me how to solve this, or tell me the answer if you want. Sure, which serial one? Is it like the longer version? It might be a longer version. How do I solve this one? Yeah, so plug in 4. Just go right here. Not bad. Take 4, plug it into the model, same as the last one. So if you're wondering, we did the last one a little more slowly. It's just saying predict with 4, so that's negative. Watch out, that's where they're trying to get you right here. 36.37 minus that number we just got, and there's the answer to 1 decimal. Delete down, and good to go if you did it right. There we go. Is there a bigger serial version? Here we go. Is it this one right here, Noel? Another serial version right here. That was less than a minute on that question. We can try to do quite a few more. For many people, cereal is the most important meal of the day. Okay, so from this model, you can estimate a cereal's potassium from the amount of fiber it has. What does it mean to say a cereal has a negative residual? So here's the model. This is the predicted what? The model's predicting what right now? Look at the equation. The model is predicting what? Don't look at their answers. Just look at the equation. The model is predicting what? The model is predicting what? This is the line. This is a linear model. Has a positive slope of 27. It's predicting potassium. So a negative residual would mean the dot is where to the line, which is the actual value of potassium. A negative residual means the dot is where? A negative residual, which these are things you should be able to do thinking through regression, how it works. A negative residual means the dot is where? Below the below the line, not below the actual. The actual is the dot. Good answers. So the dot is the actual. How much potassium does it actually have? The line is the what? Think of a P word. The line is the what potassium. So when I draw this out here, I think, well, we kind of have it here. So yeah, we could put a negative residual. So the line is the what potassium? Predicted potassium. So the blue one has a positive residual, and now the orange one has a negative residual, meaning that its actual potassium is lower than predicted. Does that make sense? Because the prediction is the line, so this dot right here has a positive residual, and this one has a negative residual because it's below the line. So anything that has a negative residual means that the potassium content is actually lower than the predicted, as long as I haven't reversed it. And there we go. It is lower than predicted. So the actual is lower than the predicted. And we'll show that here visually. The actual, which is the dot, is lower than the model, which is the predicted. And hold up your arm like this during the test if you want and be like, okay, here's the dot. This is the actual, what it has actually. And what do we mean by that? We mean if you trace over here and you get something like 315, that's how much it actually has, but the model predicts it would have like 317. So this would have a residual of what? If it's predicted to have 317, I'm from New York. So if it's predicted to have 317 and it actually has 315, what is its residual? If it actually has 315, careful. -2. Great job, Christopher, right there. -2. We'll write that into the formula. Remember, residual formula is residual equals actual minus predicted. Actual minus predicted. I almost went residual equals actual minus predicted. And no worries, no worries. And then -2 equals to 317, or whoops, see, I'm making mistakes right here. It actually has 315 according to this fake example. There we go. You can get one more done right here, but we're hitting lots of knowledge, and it's just practice, practice, practice. What does it mean? Wait, we just did that one. I was like, is it a repeat? Explain what the slope means. For each additional what? What's the slope for this question? Don't read their answers. Don't read their answers. What does the slope mean? Table? Yeah, LabBurst. Here, we'll do that one. It might end office hours. Probably will, because we're running up on time here. But what does the slope mean? No, we'll do it. Well, the value of the slope is 26. That is B1. Good answers, Braden. That is the coefficient of the slope, which is 26 right there. But what does the slope mean? For each additional what? For each additional what? What does the slope mean? Not increase in potassium. Good answers, Christopher. It's going to be for each additional fiber. Just think about this. If you go to this equation and you plug 0 in for fiber. Ooh, I can do that. I was like, can I zoom in on this? If you plug 0 in for fiber, what does the equation solve to? If you plug in 0 for fiber, what does the equation solve to? So if you plug in 0 for fiber, what does the equation solve to? 35. If you plug in 1 for fiber, what does the equation solve to? If you plug in 1 for fiber, what does the equation solve to? If you plug in 1, it solves to what? You got to do a little math now. 61. If you plug in 2, it solves to 87. So wait a minute. For each additional gram of fiber, we expect potassium, I should have put that there under potassium, we expect or predict potassium to go up by 26. Does that make sense mathematically what I've done? For each additional gram of fiber, potassium is predicted to go up by 26 units of potassium. Does that make sense, like mathematically? So just think about when you write it, for each additional 1 unit increase in X, we expect Y to increase by B1. Which of these looks most like this? The model predicts that cereals will have approximately 26 more grams of potassium for each gram of fiber. For each additional gram of fiber, we expect potassium to go up by this amount. So the answer is C. Great job, Christopher, right there. They just put it in reverse order again. They love doing that to me. For each additional gram of fiber, the model predicts potassium to go up by 26 because potassium is what is increasing for each additional gram of fiber. I know, Christopher. Man, we'll give you some just like all the wows in the world. Mubot's not here. They did put it in milligrams. Apparently that's the units. It is in milligrams. Yep, for potassium's in milligrams. Apparently you don't want a lot of potassium. You don't want all the potassium. Live burst to end class. Where is it? The correlation. What is the fraction of variability? Just square it. We've done a lot of the toughest ones. There you go. Right in the nearest tenth. What is the fraction of variability? Just square it. The negative sign doesn't matter. And nearest tenth. Yeah, let's do that one next. I'm like, how much of this can I get done during office hours? Right, sense what R squared is. 67.6% of the variation. Home price. A linear model on size. So they're using size as the X first. Counts for the blank percent of the variation. Home price. That is R squared, so that should be right. Residual plots. The fan pattern indicates the model is getting weaker. Power decreases. That has an outlier. Except for a single point outlier. Model's getting stronger. Explanatory power model increases. Oh, whoa, wait. No, I said increase. It's decrease. Yeah, it's decreasing right there. Wait. Decreasing power. Oh, it's this one. Yeah, it's increasing power. I saw increases. And this is increasing power because model's getting tighter. And same thing. Model's power is decreasing. Model's power is increasing. And this one has a bit of an outlier. Same ones? Sure, same ones. Noel. Oh, darn it. Well, is this live burst? That one can be done kind of quickly. Okay. Okay, here we go. Live burst. Finish off office hours. That was just some quick ones right there. I got one wrong. Okay, table shows the number of live bursts. Let's do this. So we're going to have to use what to solve the problem? Tell me the three-letter word. Nice. Nice. We're going to use what three-letter word? Clay, good to see you. Nice polo. Oh, thank you. Yeah. Haslam polo today. What three-letter word are we going to use to solve this? What three-letter word? This is a tough one. I'm going to try to do it. I'm going to do it quickly, Noel. I have longer videos. I might just solve this one on my own right here. You ready? If this question goes too quickly for you, please check out one of the videos where I go a lot more slowly through this. And I put the wrong timestamp. That timestamp is so far off on this. It should be at 53 minutes. How did I even put... I thought I just delete... Don't. Okay, good. Okay. So this question, I highly suggest watching the videos where I go more slowly through this, which I do have, and you can use the search feature on YouTube by going to the channel. I'm going to show you that in case people are wondering. If you go to the channel... And I'll even put a link in here because if we go to live bursts on the search feature, you will see office hours right here. We're in another black polo, but different black polo. Long time ago question right here, the table live bursts, and look how long it takes to solve. This one is not a quick question. Chapter 7 and 8 today in class. So here's one of the many videos where I go through it right here. It's linked right there. I don't know if I timestamped it, might not have. Here's another video from October 17th last year. And if you look right here at the table of live bursts, at the end of office hours right there, if you look another long time going through that. Yeah, and so I probably don't have enough time. I could try to speed run it really quick. We're just running low on time. August 3rd, no way did I do it this early in the semester. Oh, I think this must be, no, this is like, I don't know what it is. August 3rd, October 18th. So here we go, table of live bursts, their birth rate. Is this it? Bye-bye, person. So here, I've done these questions a lot if you can't tell. So there's multiple timestamps going through the question. I'm going to speed run it right now. So let's go ahead and speed run this. So it looks like birth rates are going down. So it's going to be this model right here. It doesn't have a parabolic pattern. That's random. That's up. Has a downward pattern. And I've done the question a lot. Okay. Describe the trend. They've been decreasing because look at the rates right here. You see them going down. Then we have to write the model. This is where usually people get stuck and they finally entered in, because they want you to do year as this. When bringing the data over, please watch one of my videos. And I have gotten this wrong before. You might see one of the videos where I make an error. Be careful. You have to go in here and go to formula, take year, and subtract 1900. Now, if you don't want to do this, you could literally just rewrite the years. So this is corrected year. And once again, you could literally just go here and start writing things like 65 and go down and write the years minus 1900. So now we go to analyze fit y by x. We put in the corrected year as the x, the rate as the y. Go over here, go to the fit line, add the line. Here's the model. So the model I'm going to put over here, or I could dual screen it. 2 seconds. Dual screening the question, and then we're going to do some class time. Okay. Once again, please watch the videos where I go through more slowly. The intercept is 25.59. Am I rounding correctly? I think I am. And the intercept is 2 decimals. That's not. Oh, negative. Do not forget negative. We already said it is a negative slope. And that looks to be correct. That's quite a small slope. Check to see if the linear model is appropriate. Yes, because it's reasonably straight and doesn't have extreme outliers. Working variables doesn't matter here. For each additional year, we expect the birth rate to decrease by this amount. For the number of birth rates, has been changed by the amount of, nope. Number of 100 birth rates. Wait, this is the slope, right? For every additional, no, the number of births. Yes, I hate the way they wrote that. What is 1978? Estimate what it was for 1978. Just plug 1978 into the model. I'm going to cheat though, and I'm going to go over here to jump. And I'm going to go to my model and go to this and go save predicteds. And with save predicteds, I'm going to enter into year right here. Can I do that? Is it locked? Oh, yeah, that's interesting. It's a formula column. There we go. Oops. Once again, please check out the video. Did I just literally? No, I didn't. Round to 1 decimal, and they don't want it. And I don't think they want us to times by 1,000. Do they want us to times by 1,000? See, that's where I get. Oh, no, they don't, because they're keeping this as this. Select the correct choice. The model predicted this many more bursts. So it predicted 1.7 more bursts right there. The birth rate in 2020 wasn't collected yet. Predict for 2020. Go back to our data. Type in 2020 and predicted birth rate is this. And go back over here. Enter into 1 decimal, and that's going to round to 12. It's an extrapolation from there is some faith. It's a small extrapolation. Predict for 2050. Go back over here. Put in 2050. It went down a good bit, and this is a large extrapolation to 1 decimal. I hope I did it right. I did it really quickly. There is no faith because it's a very large extrapolation from the model. 100. There we go. That's a tough question. I do not suggest going through it at the speed I did. I basically used a lot of statistical software to solve it by using the save predicteds and the formula column to get things rather quickly. Just wanted to show, at least sometimes, because I do questions for like 30 minutes, but a lot of it's teaching how to do it and explaining the why of why we do it. But with that, we're gonna have class here in 11 minutes, so I need to go. Class time soon. Bye for now, everyone. You're welcome to check out the videos. There's 3 links. If you watched me do that quick explanation, one of those 3 links is probably gonna resonate with you, and you'll see how to solve it step by step, a lot slower than I just did it. Bye!